Today, you're going to be practicing solving quadratic equations using the square root property and solving quadratic equations by completing the square. Your homework tonight will be page 345, problems 2 through 4, 8 through 9, 11 through 12, 20 through 22, 27, and 29. Here's a little humor for you. How does a ghost solve a quadratic equation? By completing the scare. So let's talk about solving equations using the square root property. There are really two steps to this. The first is you want to isolate the x squared term. Once the x squared term is isolated, you're going to be able to take the square root of both sides and solve for the solutions for x. You know you can use the square root property anytime the middle term is gone, meaning there's no x. There's an x squared, but there's no x. If there's no x, you're home free for using this property. So let's isolate x squared on example 1. We need to get rid of negative 4. How do we get rid of negative 4? I'm guessing you figured it out by now. We need to add 4 to both sides. The next step, we need to get rid of that 3 in front of the x squared term. So we're going to divide both sides by 3. Now we're ready for step 2 of solving using the square root property. You need to take the square root of both sides because we're not looking for x. We're not looking for x squared, we're looking for x. So we're going to take the square root. When you do that, you end up with x equals plus or minus the square root of 24. But the thing is that you can simplify the square root of 24 more. You can find perfect squares that are underneath that radical. You can factor out perfect squares from 24. Again, perfect squares are things like 4 and 9 and 16. So find the biggest perfect square that goes into 24 and factor it out. When you do that, you're going to realize 4 is the biggest perfect square. So square root of 4 times the square root of 6. And then you have one more step. You could rewrite this square root of 4 as a 2. So your final answer is going to be x equals plus or minus 2 square roots of 6. Using what we just did, see if you can figure out example 2 on your own. So pause the video and then unpause it when you think you got it and check your answer. All right, so we need to get x squared by itself. So we're going to subtract 40 from both sides. To get that 2 out of there, we need to divide both sides by 2. All right. We're trying to figure out x, so we need to do something to this x squared. And to undo a perfect square, you can take the square root of x squared. What you do to one side, you must do to both sides. So we have the square root of x squared equals the square root of negative 25. On the right side, on the left side, you just have an x. On the right side, we have plus or minus the square root of negative 25. Now, just a little reminder, the reason we have to write plus or minus is because when you take the square root of an x squared, there may be a negative value for x that would also work. Because when you square a negative value, you get a positive one, so you just can't tell whether x is negative or x is positive. So you have to look at both possibilities, and so that's why we write the plus or minus sign. Now, turns out you guys have learned something that allows you to simplify a negative number underneath a radical. you've learned a special imaginary number, and it's represented by a variable. That variable is I. So we can write this as x equals plus or minus the square root of -1 times the square root of 25. And then this part, which I was just alluding to, turns into what letter? That's right, turns into an I. Because I is the square root of -1. That's the definition of I. Now, the square root of 25, you just write that as 5. And I'm going to go ahead and put that in front of the I term. That would be the way we write that in standard form. Okay. Let's try a few more. Actually, this one, let's just not do it. Let's cross it off. There's a problem with this. We can't use the square root property when you have an 8x in there. So this, although this is solvable, and you're going to learn how to solve this a little later today, we're not going to work on it right now. So jump in, see if you can do this problem right here. I'm going to isolate the x value. So we have 4x squared equals 25. What's interesting about this one, and this is where being good with fractions really helps. Okay, so we're going to divide by 4 on both sides. And you'll notice that you get something that isn't really pretty. It doesn't have, it's not an integer. You have 25 over 4. So we have x squared equals 25 over 4. I want you to leave that as a fraction. You're going to see why in a moment. You don't want to write that as 6 1/4. That's confusing. Because when you take the square root of both sides, look what happens to this radical. You're going to have x equals plus or minus the square root of 25 divided by the square root of 4. This is going to simplify nicely in its current form. You know what the square root of 25 is. It's 5. Square root of 4 is 2. Now, same steps in this one. Challenge yourself. Pause the video. Come back when you're done. We're going to subtract 21 from both sides. So we have 3x squared equals -45. Divide by 3. X squared equals -15. Now, probably get an idea of what your answer might look like when you see that negative sign, because you know when you square both sides, when you're squaring a negative, you're going to get an imaginary number. Don't forget the plus or minus sign. So we're going to have x equals plus or minus the square root of -15. We got to keep going. We don't leave negatives under the radical. We like to write them with imaginary numbers. Tell that to your friends. No, I prefer to write my radicals as imaginary numbers. I just like it. Here we go. So we're going to write this as x equals plus or minus. I'm going to factor out the -1, which turns into I. So we have I times the square root of 15. And you could write the radical in front. We're going to put imaginary number in front of that. So this would be your final answer. And that would be it for simplifying using the square root property.